Hello, hello. You are all here. You are amazing. You thank you all for being here. You, if at some point you can, okay, wait, more people are coming. A little bit good morning, good morning. All right, this is good. This is helpful. If we're not going to show video, at least take it right. Okay. Good morning, Tania. Good morning, Yiyun. Good morning, Matthew. Excellent. Thank you for saying good morning, Anjali. Good morning, Claudia. Good morning, Sharon. Also, good morning, Jonathan. Oh, some video. Thank you. Good morning, Melita. That is very helpful, especially at this hour and under these circumstances. I appreciate it. Good morning. Who was I up to? Good morning, Claudia. Good morning, Sharon. Good morning, Jonathan. Good morning, Melita. Good morning, Billy. Okay, we really have a full house. That's awesome. You guys are you're reliable to the end. Good morning. All right, we will start in a sec. Good morning, Eric. Oh, okay, we can hold back on the good. Fair enough. It's a morning. Yes. Okay. Um, good morning, Francis. Wow, this is a quorum. This is like everybody, I think. Wait a minute. Amazing. One, two, wait, sorry. One, four, 7, 10, 12. I think it is everybody. Amazing. You guys are very impressive. Okay. And I know this is an awkward way to end the semester. Um, and I feel terrible about that, but I feel great that you're hanging with me and I appreciate it. Okay. And if at some point during the day, like not now, but if at some point each or any of you could show, well, one person already is, but a little video here and there throughout this, like basically 1 hour would be a little helpful to me just to make sure we're all together. But I totally get it. You're all here clearly. Okay, but thank you for those people who are showing video. Okay. So we're here to tie up loose ends, mostly to make sure that everybody is set and not worried and okay and strong and confident or clear on what has to happen to shut down this semester and hopefully with a good grade. Like that's number one order. So a lot of what we're going to do today is like just making sure that any of your concerns or your questions are addressed, like about how to end the semester with a good grade. At worst, so I'm going to answer questions. I'm going to say things. A lot of them will be logistical. At worst, if nothing else, by the end of today, if like you have a question that's so complicated or you're so concerned or it's so personal or something, then at worst, we're going to end today by you having my contact information. And at really worst, if you're super panicking, then before I go, if any of you needs to literally make an appointment with me, like before we shut down so that you know it's in the books, like that's fine too. If nothing else, this is an opportunity to make sure that it's not that you can still reach me before the semester ends, okay? So there's going to be some logistics, actually a lot of logistics. There's going to be a little physics. I'm going to give you the last final thoughts on physics that will help you for the final and that will also sort of tell you the point of why, in my opinion, of why you've been slogging through this for 2 semesters. But it's going to be also short. Like, so the deal is I've even set an alarm already for myself, but you can trust or help me that by 9:40, in other words, in an hour, I want to be shutting down. I want you to give me a grace period, like just in case I'm right in the middle of something tremendous or something. I may take a little grace period and I'll go, I might go up to like 5 minutes to 10. I'm going to try not to. But at worst, like 5 minutes to 10, we will shut down. You can remind me to shut down. Like you should be out of here by 10. And I need to also. Okay, so you can help me make sure that happens, but just so you're also prepared. So basically, this is like a 75-minute class, like a single period class. Okay. And again, it's largely so that we all, don't panic. Of course, okay. So let me go in a strange order. First of all, I'm just going to check right now. I appreciate that you rolled with my approach to the teacher evaluations. I'm just looking for a second just to make sure. I definitely, no matter what, I hope you understand, and I hope you know from last semester, I absolutely cannot see like how you evaluated or what you said or anything like that. The only thing, yeah, that okay. If you had posted any kind of like screenshot of you turning it in, and that's all I hope you posted. I hope you didn't post any, where I'm looking right now. Yeah, so many of you posted a screenshot of saying you turned it in. In fact, anybody who did that, I'm gonna give the points right now. Anybody else, if you're not from this school and you don't have, and you can't do it, which is really weird, but I know that's true, that if you're not actually a John Jay student, they don't have it set up for you to do this, and that's a mistake, and I have to bring that to the committee. But that's true, though. It's not your mistake. Okay, so if you can't do it, just write me a note that says I'm not from John Jay. They won't let me, and I'll give you the points for trying. As long as you but as long as you did it, I'm giving you the points right now. If you haven't done, so I promise you I can't see what you say about me. That but it is actually really important to me and to the school that you do them. I think I mentioned this last semester. They actually make much more of a difference than students think. And I've been on the committee for years about these things. We're working on ways to make them make more of a difference, not less. And we're working on ways to make them better. And we're working on ways to make it more clear to students exactly what a difference they do make. But they really do. And we really can't see them. Even me on the committee, I can't see what anybody says about anybody. And that's the way it should be. But we can see like how many get done. Okay, so that's a long way of saying most of you look like you've done it. Whoop, sorry. So thank you very much. If you haven't done it yet, I'm gonna ask you to, oh, wait, okay, wait, I'm looking at them right now. So if you're turning them in right now, that's great.
Tanaya wrote in the chat that she can't do it.
Right, okay, and I'm looking at, oh, she wrote in the chat also, okay, because, wait, she is because she's not a John Jay. Right, all right. If you're not a John Jay student, I totally understand, and I'm giving you the points anyway. Okay, so it looks like so there's a couple of you, and again, I can't see the results. And also you don't have an obligation to do them. Like if on principle you don't want to do it, you can even tell me that. If you want to write a note that says, I don't believe in these, or I protest these, or whatever, that's fine too. I'm not, it's like voting. Like you have the right to not vote. I just don't want you to just accidentally not do them. So if you want to write me a note that says, I don't believe in these, that's fine too. And I'll give you the points. Okay. It's not like I just want to make sure that everybody's taking the moment to think about it. So there's a couple of you still. So if you still are one of the couple of people that haven't done anything about it yet, please, I think the deadline of the school is till tomorrow. So as long as you do it and you submit proof, I'll give you the points. All right. So that's that. Okay. But again, thank you. And, thank you for doing that. Okay. Wait, so sorry. What I'm looking at the chat. I'm going back and forth. Okay, right. So if you can't do it, right. Okay. That's that. One other logistical thing that I have not posted that I will post, the board meeting that you did last week, which thank you very much. And that was actually instructive and fun for me. It was nice to be with you as a group that way, actually. That board meeting, there will be a survey that will be put up in Blackboard, even though we've never used that. It'll be linked to you from Google Classroom. The survey's not ready yet, like someone else makes the survey, but as soon as that's ready, I'm going to put it up. And so anytime before, I'll put a due date on it, but basically anytime before you turn in your final or along with your final or consider a part of your final, please do that survey. And again, we won't see your results at all, but you'll be able to screenshot a thing that says that you've done the survey. And it's literally a survey. Like it's not about me. It's not about you. It's just about like your relationship to physics or science. So I will put a portal up separately for that, where you will get extra points for doing that. Again, like I can't force you, I won't force you, but you will, and I will give you a ton of points for doing that because it just helps everybody. So just look out for that. Just know there will be a portal while you're taking finals to just do that. And it takes like 7 minutes. Okay. Okay. So that's that. Other logistics, if you have And at any time, whatever you're concerned about this end of the semester, obviously ask me or ask in the chat. Like you can, I mean, we're here to answer questions. But as far as other logistics are concerned, you still could hand in old homeworks by tomorrow. Like especially if one or two are outstanding and you want the points, or you did one at one point, but you didn't get a big score, but you got feedback, but you never dealt with the feedback and you want to revise it, that's fine. You can do those things by tomorrow. You can also turn in any of the special game turns, like showing video or talking in class, like all the special ones that they're all technically due, I think, tomorrow. So you can do any or all of those for more points still by tomorrow. Regular game turns, like the weekly game turns, don't worry about doing those for tomorrow. It doesn't make any sense. And the other thing is, yes, you can hand in homework by tomorrow if you want for the points, if you're concerned, but don't hand in like a huge pile of like all the homeworks from the semester. Like if you've never done homework to this point, don't now scramble to hand in a big pile of all of them, because first of all, your time will be much better spent just trying to do the final. Your grade will benefit much more if you just try to do the final. And also, if it's too big of a pile of all back homeworks, there's almost no way it can be authentically your work, and we both know that. So at a certain point, handing in too much at the last minute just looks very awkward and uncomfortable for you and for me. It's like very sus. So it doesn't serve the purpose. So just, you can tie up loose ends by tomorrow, but don't like try to redo this whole semester in one night. Oh, is that a question? Oh, yeah, Melita, sorry, go. Yeah, absolutely.
If I did like some of the homeworks from spring break that like then you took down as homeworks, but like I had done them over spring break, could I submit them for
Oh,
points?
yeah, sorry, absolutely, yes.
Like they're still there as portals. They're just like not required. So I didn't know if to like submit.
Right. No, good point. Absolutely. Anything that I stopped requiring is not required, but absolutely any work you ever did, yes, you can turn in for points. Yes, absolutely. I mean, you won't get feedback, but you'll get points.
Thank you.
Absolutely. Yeah. And for that matter, also, that reminds me, there's one portal that confuses people a lot that often people don't take advantage of, but it's sort of worth knowing. If you're worried at all about your grade at this point, and we're going to address that in a second. If you're worried about your grade or something, a couple things to do, but one thing is there's a portal that's called a game portal that's called Your Best. If you put in anything in there, you'll get all the points. First of all, if you just put anything in there, you'll get all the points for that. And it's like it's quite a few points. It's like 18 or something. But the purpose of that portal, Your Best, is we all have good days and bad days. And the problem with the way a lot of grades are computed, as you know, in life, is a lot of times grade averages, like grade you on sort of your middle, right? They sort of like try to not punish you for your worst day, but they don't really reward you for your best day either. Regular grades, I mean. So the point of the Your Best portal is particularly applicable to this class. All of you have made like a huge commitment to be here at 8 in the morning and all of that in person and stuff. So all of you had at least one assignment or one midterm or something where you really know you rocked. Like maybe you had maybe things fell apart in the middle of the semester because you were taking 85 other courses, whatever. But there was a moment for each one of you where you were totally on your game and you totally knew what was going on, and you went to town on a particular assignment or the midterm or something, or even a lab report, actually, I guess. So my point is, if you have one assignment anywhere where you just know this was your fine work, this was really you at your best, and maybe you got a really good grade on it, and that's helpful, like you saw that I loved it, or maybe even not. Maybe just like, and maybe you never got real feedback on, but just like, this was a day where you really understood things, or you took amazing notes or something. Just your best. If you have a piece of work that you'd like to remind me, this is who you are at your best, put it in that portal. Because especially if at the end, like you're right on the borderline between two grades or something like that, I like to be reminded of people at their best. I prefer to judge people at their best than at their middle or their worst. That's the whole grading system sort of designed to help do that. And I also like to know that people know when they're at their best. Like it's cool for me to, if you show me an assignment that you rocked from early in the semester, and not only is it really good, but I know that you know by putting it there that you're like, yeah, this is what good physics looks like when I do it. it helps us both psychologically a lot. So just, especially if you're concerned, or even if you're not, if you have one assignment or one document or one thing or one set of huge class notes that you're like proud of, put it into Your Best portal. You'll get points. And I always look at that right at the end. I just fast look through that portal just to see like where people think they are. And it helps elevate your impression in the final moments and my memory of you. Okay, so that's that. Now, also in terms of being concerned about grades or whatever, at this point, I believe everybody who turned into midterm like has gotten it back. I think most of the grades are more than fine. Some of the grade more than fine. Like I think some of the grades are higher than others, obviously. But I want to break down now that you have them. I want to make sure you remember how the grading system works. And I want you to know that that nobody should be panicked in this group. If like there were some, I'll start with this. First of all, if I haven't reached out to you and said there's a big issue, like you might be failing this course, like F or D, if I haven't reached out to you and said that, that's a good sign that I don't think that's what's happening. If you're concerned you might get a D or an F, definitely you should reach out to me before the final exams are in. Okay, but I don't think that's an issue, really. I don't think off the top of my head, now that I've seen all the midterms, I don't think that's an issue for anybody in this room. If you got something in the 70s on the midterm, okay, let's just be clear and real. If you got something in the 70s on the midterm, what does that mean? Okay, first of all, does it mean you're getting a C in the class? Probably not. If you got probably something higher, okay, just to be clear, if you got something in the 70s on the midterm, it does mean you want to do better on the final. So we'll talk about that in a minute. Like it does mean you don't want to just totally chill out yet. If you got some, I mean, assuming people don't want C's. If you got something in the 70s on the midterm, it does mean you want to do better on the final. And it does mean that as long as you do better on the final, you're still in firing range for some kind of B or something, which is totally reasonable in the science class, obviously. Okay, so there's, if you got something in the 70s, you have motivation, I think, to work hard on the final, but hope is not lost at all in terms of, I mean, it may be very hard to get an A, but you can still definitely get something in the B range if you got something in the 70s in the midterm. And so on. And if you got something in the 80s in the midterm, if you got something in the 80s, it does not mean that an A is out of the question for you. It means it's not guaranteed. But you should remember, all of you, when you're going into the final, I'm going to remind you for the last time, just because I know it's very complicated. I mean, the grading system's in the syllabus. It's the same grading system I used last semester, but it's worth me reminding you because it's an unusual grading system and I don't want to deceive anybody or trick anybody or have unnecessary anxiety. Remember, the basic grading system works like this. You have three big numbers in your grade: your final lab average, your midterm score, and your final exam score. Those are the first three big pieces that matter. They get averaged together in a regular arithmetic average, but it's not 3 equal thirds. Usually what I do, and I'll do this semester, usually I count the exam that you did better on. I more heavily weight the exam that you do better on, okay? And usually what that ends up meaning is that first I take those three numbers and I double, usually, I mean, it's kind of dramatic, but I double the one that you did better on. So what ends up happening is your better exam counts for like 50%, your worse exam counts for 25%, and your lab counts for 25% of like your, basically, of like your base grade. And then all the points that you ever got on any homework, any game turn, all of those points all are in a huge pile and they get scaled down. They get divided by a number, which changes every semester. So I cannot guarantee you what the number is this semester. It changes because it's like a weighting factor, but it's the same for every single student, no matter what. It's just different every semester. So say that number is something like 25. Then if your total, this is just also so you can help yourself predict your grade, because whatever Google Classroom says is your grade, that is not true. I have to also be clear about that because my grading system is more complicated than Google Classroom understands. So the way to predict your grade, if you're worried about it or thinking about it before you go into the final, is take those three, like take your midterm, your projected final exam grade, your lab grade, count your better of your two grades twice, or like your predicted grade, whatever, put those together. And then all of your points from all of your homeworks, add them all up into one grand total, divide by something like, to predict, like 25. So say you have 200 total homework participation game points, whatever. If you divide that by 25, that makes 8. So 8 would be the number that you would add to your base average from the other things, like from the lab and the exams. So you would take whatever that base average is from that, and you would add 8 points to it. Again, that is not a perfect prediction. That's not perfectly accurate for the semester, but it's reasonable, and it's reasonable. It's typical that if you did a lot of homework and a lot of participation, you're going to add something like 8 points to your average or something. And that will be your final average. And then for I usually give 1 extra point for what I sometimes call citizenship, and sometimes I call engagement, sometimes I call initiative. It basically is the old-fashioned version of participation. It's just that we already have so many participation things that I don't use that word. But you can get 1 extra point if you've been very present and engaged and active, and I know who you are, and you've made a contribution to the class, and that usually applies to most of you that have been here in the morning. So that 1 extra point is for that if still after all of that, you're right on the bubble between 2 grades, you get 1 extra point if you've been a reasonable citizen, to make sure that you fall on the correct, desired side of the borderline. Okay, I know that's over-explained, but I just want, so that you can predict what's going on when you go into the final, so there's no mystery. Just raise your hand if that's basically clear, if you basically get how the grades work. Okay, that's one person, thank you. Okay, raise your hand if you hear, oh, that's Eric. Okay, thank you. Raise your hand if you hear me at all right now, people. Okay, that's good. All right, so the grading system is basically clear? Okay, all right, thank you. All right. So then also the final, as you know, you have a practice final in your possession already. We'll address that in a second. But the actual final will be posted. Oh, and I have to remind myself. The actual final will be posted no later than 8 p.m. tomorrow, Thursday night. Hold on, I'm making a note to myself so I don't forget to do that. Sorry. Okay. And if your hands are up because you were acknowledging, you can put them down. But if there's questions, if those are those, Jonathan and Billy, are you okay? Billy, do you have a question, or you're acknowledging from before when I asked you to raise? If you have a
Just
question,
acknowledging.
oh, okay, thank you very much. All right, awesome. All right. So the final will be posted no later than 8 p.m. Thursday, as you know. It'll be due back no later than midnight on Monday. If you're gonna have a problem with the time, you have to let me know. We can't mess around, especially with final exams, because then the grades are due very, very fast, blah, blah, blah. So it's due midnight Monday, same routine as always. It's open universe, all that, untimed, all that. But now that I've seen your midterms and you've seen your midterms, I'm going to give you some advice about it, or some pointers. I'm not going to walk through okay, first of all, the practice exam, it will be no longer than the practice exam. It will be shorter, in fact, substantially shorter. It'll be pieces of the practice exam. It won't be the whole thing. It'll be no longer than your midterm, and hopefully even maybe shorter than your midterm. Like your midterm, you'll have some kind of choices or something like that, but the material will basically resemble what's in the practice exam. If there are things in the practice exam that look vastly unfamiliar to you, that means they're probably, if they're vastly unfamiliar, I'll scale them down or take them out or whatever. But if they're sort of unfamiliar, that probably means that they are covered in the 2 videos that I just posted right before this class. So if you get to anything, if you choose a problem in the final exam and you basically like the problem, but then there are parts in the problem that you're like, wait, I don't really know what this is, I highly suggest that you check out the 2 videos that from last semester that I just posted. It's probably in there. It's definitely in there. The extra document, you'll notice in the practice exam, there's 2 pieces. One is an extra document, like a Google form, that's like true, false. That I may or may not include a true, false section in your exam. If I do, it'll probably be a choice like anything else. If I do, it won't be those questions, it'll be different questions. And it'll be largely based on whatever last physics things I say today, whatever last physics things I said like the last couple of sessions. It won't be as long as that one if I do it, and it won't be the same questions, but it is possible that one of your choices in the exam will be a short true false section. So warning about that. In some ways, true false is much more appealing than anything else because like you don't have to show work. You just, you can flip a coin. Like, but obviously my true falses are on material that is not easy. So I wouldn't do the true false unless you look at it and you feel like you kind of do understand the material that I'm asking about there. So don't over prepare for that is basically what I'm saying. Like if you're trying to prepare or get a sense in advance before Thursday, I would really focus on the rest of the practice exam document. We're not doing a walkthrough of it today or anything like that, but I do promise you that if you go back to the old YouTubes from like summer of 2023 or spring of 2023, for sure I do walkthroughs there of various parts of this final, and that's all public. Like I can't take the initiative of doing it, or I'm not going to do it, but you're welcome to consult all those materials if it's helpful. Okay, now as far as doing the final, some words of advice based on the midterm. Again, if you did really well in the midterm, you can give yourself a little, then you don't have to work as hard at the final. You still have to take it though. Like a 0 would not help your grade. Everybody has to take it. But I think the people that are most committed to the final, the people that are a little concerned about however they did on the midterm. So a couple of words of advice. First of all, yes, you can all help each other. And you should, and especially those of you who rock the midterm, maybe if you want to help other people, like you can and should for the final. But I do want to caution you that once you've helped one another, then go back into your own private room and fill out your own private document, not as an ethical issue, but because there's no guarantee when the whole group gets together. Yes, it's largely helpful, but sometimes the whole group comes to conclusions that are not necessarily right. And you want to reserve yourself time at the end to make your own autonomous decisions and your own autonomous decisions about how you present the material. Because what I definitely saw in the midterm in both classes is, first of all, there were definitely places in the midterm where for sure everybody did it together. And it's fine. I said you could, but there will be places where everybody like figured out answers together. But for sure, some people understood those answers better and how they got them better than others. And for sure, they presented them in a much more thorough, convincing way. And I already know there's always places in the midterm where two people get the same answer, but they don't get the same marks on it. Like one person still loses more points than the other. And then the people are like, wait, we got the same answer. How come she didn't lose any points and I did or whatever? And the answer is, because the exam's not about answers, it's about how you prove the answers and derive them and present them. So first of all, please know that even when you get stuff from your friends, then go back and show that you understand it, because that's what you're being graded on. And don't assume that just because two people have the same answers, they're going to get the same grade. That's number one. Number two, this happened mostly in the other class, not so much your class, but there were some pieces of that exam where like a lot of people did the same thing and it wasn't the right thing to do. And so I'm just warning you, like, just give yourself time at the end to trust your own intuition after you've collected data from all your friends. Okay. Specifically, make sure that any problem that you solve, you start with a diagram, no matter what. The diagram should be of the facts, not of analysis. If the problem is strictly mathematical, then sure, you could start with a graph because it is mathematical straight from the start. But if the problem is physical, don't start with a graph, start with facts. Sorry, I didn't. The diagram is supposed to be of the situation as it is presented, and then you do analysis from then on. Make sure you always tell me exactly where you are, like what problem you're solving after you make the diagram and you start to solve it. In other words, do the 5-step method to the end. Okay. Oh, something's in the chat. Sorry. It might have been for a long time. Oh, right. Okay. Right. So it's funny. I just said that. Right. For any problem solving thing, you do the 5-step method. But if I put true false on the test, and if you choose the true false section, right, you don't have to show any work at all. You don't have to do 5-step method on a true false. Again, the true false is kind of attractive in that way, but it's kind of deceptive also. Like the questions aren't meant to be tricky, but they're about tricky material. So don't underestimate the true false, but if there is, and if you choose it, but right, you don't have to show any work. That's right. Okay, I've been babbling a lot. Oh, and it's already 9:12. So I'm just trying to make sure I think I've covered my big basics. So let me pause for, oh, and I'm gonna put my number in the chat again before. I'm not gonna be in my office today. I'm not on campus today, as you can tell. So I'm not available for like in-person discussion, but if you want to make an appointment or Zoom or talk on the phone or like if there's any big concern before Thursday or next Monday, that's my cell number. You can text me. I mean, obviously you can email too. Once the exam is posted, then I can't help you directly with the exam, of course, but if you have questions about your grade or whatever. Okay, I have one more larger thing I want to. Well, I'll say this before I forget, and I'm going to turn it to you for questions to physics. Again, I feel a little bit bad that I'm ending the semester like in Zoom this way. It is what it is. But I do want to make it clear again. I think I told you this last time. You were devoted from the start for choosing this class, and you've been committed from the start and to the end. Like here we are, here on the like here you are, all here under these crazy conditions. And I got to know, and if I didn't already feel like I was getting to know you people from being in person, I feel like I got to know you at another level last week when we did like a strange board meeting. So all that is to say, please, when all this is over, I want you to do well. I hope you do well. I hope it all works out. Like if there's I hope your grade works out and all of that. And I hope you like physics at the end. But either way, I know that I know you people now. So I hope when the course is over that you feel free. I guess I did say this last time. Okay. But please do feel free to track me down by email or cell and ask me for any help that I can give you to support your future ambitions, whether it's summer internships or graduate school or jobs after you graduate, like, or jobs here on campus in the labs or in physics. I'm in a position where I can write you a fairly informed, articulate, specific letter. And it's the least I can do for many of you. So please don't be shy about that. If I really think there's a problem and I can't write you a strong letter, I will tell you, but I would never write a letter to burn anybody. I would never write a critical letter. I only write letters that are strong. So feel free to take advantage of that. Okay. All of that said, there's a little physics I want to do for the next half hour, but let's pause for a second. I want to make sure. Do you have any concerns or questions or curiosity or like anything you're worried about general grading or the general exam period or how it works or anything like that? I'm going to pause for a second to make sure. Oh, oh, you're welcome. No problem. Thank you. Okay, I'm not saying this is the last opportunity to ask questions, but it is the last clear, easy opportunity. So I'm going to do this the other way now. So first of all, so raise your hand if you can hear me speaking right now. I mean, your electronic hand. Raise your electronic hand if you can hear me speaking right now. That's one person. Okay, cool. That's a lot. Keep them up for a second. Keep them up. Let's make sure we're all okay. Okay, cool. We're almost all here. You're raising your hand if you, okay, cool. So now I want you to keep your hand. How should I do it? Put your hand down now if you have no questions and you feel like you clearly know what's expected for the next week and how to close down the semester. Like put your hand down if you feel like it's clear what to do. Okay. All right. Cool. Oh, and all right. And okay, cool. Okay. Great. Oh, wait, and I'm looking in the chat. Oh, I think I did. It was a thank you. Okay. Awesome. So that's awesome. So we're going to do a little physics for like I said, like a half hour or so, just to tie this together. And and what I'm going to say now would be possibly if we do have any true false questions, they would sort of be about the kinds of thing I'm going to say right now. All right, I'm just going to change the view of the screen so I can. Sorry, last question. So I know how to do this. In this class, I believe we had our moment in person, like right before break. The last time we were in person and we weren't in a board meeting, we had that moment where I read you that quote. I read you that quote that was written from the letter to Newton's hero, right? Yes. Okay. 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 And we already know that was Newton. All right. Great. That's what I thought. Just to make sure. All right. So here's the thing, like, what's the purpose of this whole class? Like, what's going on in physics 204? I want to remind you in our last minutes together that we had like three pieces to this course, basically. We had simple harmonic oscillation, we had wave propagation, we had fields. Okay. Simple harmonic oscillation is like, well, a very heavily mathematical transition from kind of classical material physics or classical mechanics to the more abstract physics that we ended this course with. Simple harmonic motion was heavy math that you definitely need for PChem and you need for instrumental and you need if you're going on in quantum mechanics in any way or in higher mathematics or science in any way. But the purpose, so that was one purpose of it. But the other purpose of all the simple harmonic motion was that we were looking at the details of how a lot of particles vibrate in a specific way because of our belief that if you put a whole bunch of particles together, material particles, and you let them all oscillate in a very specific way, if you let them oscillate in a pattern of space and time, then that big arrangement of particles will send a pulse known as a wave from one end of the particles to the other. And that wave is something that really, really matters in space and time. It really, really matters in nature. It really, really matters in the universe, but it isn't matter, right? The wave is our first example of an unthingy thing, or of something that's very, very real and really makes a difference in the physical world, but isn't material, isn't physical in and of itself. Well, it isn't material, right? A wave, what is a wave? A wave is information in motion. It follows all of the physical laws of motion, but the thing that's moving is not a thing. That's what a wave is all about, right? And so we studied it. So it's something that matters that isn't matter. Then we moved to all this electricity stuff. It seems like totally unrelated in a way. And you did circuits in the lab and we did fields in the classroom. And what's the purpose of all of that? Well, a field is a next example, a next huge, super important example of something that really matters in nature, in space and time, in the universe, but isn't matter. A field is real. Fields are real, but they're not material. They make a difference, but they're not tangible. They're not countable. They're not discrete. They're not separable. They're not massive. Okay? That's what fields are. Now, what are fields? Fields are raw information. Again, like when we say that we put a proton here and it automatically produces vectors everywhere, all through throughout the entire universe, that by putting one proton in the universe, there are vectors sticking out everywhere in the whole universe. Or if you like the more sort of advanced version of that that's discussed in the videos, instead of field vectors, field lines, two different representations, two different ways of picturing the same idea, which is that when you put a proton in the universe, all of a sudden information describing that proton is everywhere in the universe, right? If there's a little field vector over here from the proton over here, what that field vector is representing is how hard and in what direction a 1 positive coulomb of test charge would be pushed if it were placed at that location, right? If a positive 1 coulomb of test charge were placed at a certain location, then because of the existence of the 1 coulomb source proton or whatever charge that's over here, because of the proton that's over here, a test charge over here would be pushed in a certain direction with a certain number of newtons, right? And that vector that's sitting there is capturing that, is representing how hard something would be pushed and in what direction due to the source charge that's sitting somewhere else in the universe. Now, why I say that a field is real and why I say it's information is that that vector is sitting there whether or not any second object ever comes along to be pushed by the first object, right? Remember, a force is something I do to you. A force is something one object does to another object. But a field is something that one object does to space. A field is one object telling every point in space what will happen or would happen the minute any second object gets there to experience the impact of the first object. Okay, so the field is raw information sitting there ready to produce an effect. Okay. Why do we believe in this? I mean, that's such a weird thing to believe in. Like, why do we believe that the minute there's one object in the world, it automatically tells the whole rest of the world how big it is and where it is, which is what I'm saying, right? When I say that the field due to a point charge is a constant times Q over R squared, I'm saying that the field means at every distance R, we know how big the charge is over here and how far away it is in what direction. The address, the vital stats, the identification of any one object is known at every other place in the universe at all times. Like, why would I believe such a crazy thing? Why would any of us believe such a crazy abstract thing? Why do we believe that there's something in the universe everywhere that we can't feel, touch, smell, or what's the other one? Feel, touch, smell, or hear? Because we see the effects of it. And very specifically, to go back to that Newton quote, where Newton himself figured out that the sun was pulling on the earth even without touching it. And even if there was stuff in between, the sun was pulling on the earth, and the earth is pulling on the moon. And later they figured out protons are pulling on electrons, and electrons are pushing on other electrons. The key thing that gave Newton such a headache over this is that it's not just that we see pushes and pulls occurring. It's not just that we observe accelerations of objects. It's that the pushes and pulls are so precisely numerically predictable. It's that we say that the sun pulls on the earth with a certain amount of newtons, even though they're not touching each other. And even though the sun's not doing anything to make this happen, the sun pulls on the earth with a certain number of newtons that's fully determined by how big the sun is, how big the earth is, and how far away the earth is from the sun. Same thing with protons and electrons. So here's the thing that drove Newton crazy and why he didn't believe his own theory of this. He believed all the math, he believed the predictions, but he could not get his mind around the idea that something could affect something else with such mathematical precision with nothing in between the two. The reason is because if you believe that the sun pulls on the earth with an amount of newtons that is specifically determined by that equation, by that formula, by the law, GMM over R squared, or in the case of protons and electrons, KQQ over R squared. If you believe that the sun pulls on the earth with a certain number of newtons and therefore accelerates the earth at a certain rate that is determined by how big the earth is and how far away the earth is, then think about this for a second. And this is what Newton thought about so much that it drove him crazy. If the sun pulls on the earth with a certain amount that's determined by how far away the earth is, then what happens when the sun pulls the earth? It exerts gravity on it, and the earth accelerates, F equals ma. What happens when the earth now gets closer to the sun? If the earth is now moves closer to the sun, as happens all the time, or farther from the sun, if the earth moves, then the R in the denominator, the R squared in the denominator, is now a different number. If the earth moves at all, it's now at a different distance from the sun. According to the equation, the force that the sun exerts on the earth is now therefore different. Right? Think about it. So it's not just that the sun is pulling on the earth through empty space without touching it. It's that the sun is pulling on the earth with a certain amount that is specifically determined by where the earth is. Therefore, if the earth moves at all, which it does all the time, if the earth moves at all, the sun must then respond by adjusting its force by pulling with a different amount. If the sun responds to the earth's new location with a different force, if GMM over R squared really equals F, or if F really equals KQQ over R squared, that means every time the R changes, the sun, or whatever the first object is, somehow gets the new updated information, right? It means if we really believe this math of universal forces, if we really believe in action at a distance, and we really believe that the numbers are precise, then we're believing every time we're not only believing that objects can pull on each other or push on each other through empty space, we're believing that every time any object moves anywhere in space, somehow it sends an update of its information to everything else, right? The sun must find out that the earth has just moved if the sun is now pulling on the earth in a different way. If R changes, the F changes. And if the F changes, that means the sun knows that the earth just moved. Now, I don't mean it consciously knows. I'm not saying the sun is a human being with a brain, but I'm saying that the information of the Earth's whereabouts must be continually being sent and updated to the sun and vice versa and everything else. That it's not just that when the things exist, they put their information in space. It's that apparently we must continually, every object must be continually sending out updates to its information so that everything else gets the new updates and adjusts accordingly. Now that is like, whoa, what? Like I'm going to say it one last time, and then I'm going to move on. But I'm saying if you believe in action at a distance, which seems impossible, if you believe in the predictions, if you believe that we put a man on the moon, or if you believe that we can predict like when Jupiter's moon is going to be in front of it, and like if you believe these predictions that we make with amazing precision about the solar system and about the night sky, as Newton did, then it means you believe in GMM over R squared. What Newton's saying is, I believe the equation, I believe the numbers, but it's crazy to believe in these numbers because it must mean that somehow the information describing where every object in the universe is everywhere in the universe, and every time anything happens in the universe, updates are somehow traveling through this information, or somehow new packages of information are being sent back and forth all the time. Newton's big question was, if the real reason that Newton did not like this at all, even though we believe in it. Well, first of all, Newton didn't like that at all. Our answer to that is yes, it's not empty space, it's a field. Like we're saying yes, the information apparently is there. Apparently, when you put the Earth into the universe, it puts information describing the Earth everywhere in the universe. And it puts it in the form of vectors or field lines or whatever. We're not saying that we fully understand fields. We're not saying we love the idea, but we're saying evidently there isn't just matter in the universe. There is fields of information surrounding the matter. All matter lives in a sea of information everywhere that's being generated by and affected by that matter. That empty space isn't really empty. It's full of vectors or field lines or whatever you want to call it. The reason Newton didn't come to that conclusion or didn't like that idea is because Newton had one really plaguing question. His question was, wait a second, how much time do these updates take to occur? Like literally, Newton was like, wait, if when the Earth moves, it sends its new address to the sun, there's only two possibilities. And it's not like he didn't think about it, but he was like, if I'm going to picture that somehow the Earth is making vectors or something and sending out the new vectors to the sun, there's only two possibilities. Either the new information gets to the sun instantaneously, right away, immediately, in no time, or it doesn't. There's only two possibilities. Either the information travels like that, or it doesn't. Either way seemed crazy to Newton. On the one hand, if the information gets there instantaneously, that means anytime anything happens in the universe, the information immediately updates. And if it immediately updates, that means it doesn't matter how far away anything is from anything else. I mean, if the information is traveling at infinite speed, then it can cover any amount of territory in no time. So that would mean that anytime anything happens in the universe, the entire universe instantaneously knows it. And in a way, that means no distances matter at all. I'm not saying it's wrong. I am ultimately, but I'm not saying that proves it's wrong. But it's a real headache to think that anytime anything happens in the universe, the whole universe immediately knows it. That means it doesn't matter how far away you are from anything else. You can affect something in like light years away just as easily and quickly as you could affect something a centimeter away. That's weird. Newton didn't like that. That's a headache. The other option that Newton also didn't like is, no, maybe information travels at a certain speed. Maybe like when the sun moves, it takes a while for the sun. I mean, when the earth moves, maybe it takes a certain amount of time. Like maybe the information travels to the sun at a finite speed. So it takes a certain amount of time for the sun to find out. And if the sun's much farther away, it takes much longer to find out. That would almost be more reasonable than distances do matter in the universe. Now, Newton didn't like that either because Newton couldn't imagine what possible finite speed could something as abstract as information travel. Well, it turns out, and I'm almost done, by the way, just bear with me. It turns out in the modern world, like in the 19th century and the 20th century, well, as of 1879, we've come to the belief that indeed there are these fields, that indeed there's vectors or field lines everywhere, which not literal like lines, but like there's information that everywhere in the universe of this proton's over here and it's this big and that electron's over there and it's that big and this planet's over here and it's that big. All of that stuff is sitting in the information in the universe as data. We represent it in our mind as like vectors or field lines. So we believe in these fields. And then we believe, it turns out, ever since a man named Maxwell looked at a bunch of field equations, the equations governing the electrostatic field, such as Coulomb's law and Gauss's law, and he looked at the magnetic field and looked at laws like Ampere's law and Biot-Savart and Faraday's law. And, oh, sorry. Okay, that's my warning. Okay, I am gonna wrap up soon. Ever since 1879, what we believe is all our matter is all point charges and point masses are living in all of these field lines, this sea of vectors or this sea of field lines. And anytime something changes in the sea of field lines, it sends a new update through the field lines. Or if you want to picture vectors, if the Earth is over here and it's making a bunch of vectors around it that point in, saying pull, pull, pull toward the Earth, gravitational pull, gravitational pull. The minute the Earth moves, the vector closest to it moves a little bit, and then the vector next to that moves a little bit, and gets smaller or bigger or in a different angle, and then the vector next to that moves a little bit, et cetera, et cetera. And a ripple flows through the vectors. Like each vector, it turns out, oscillates harmonically, and the oscillations are staggered, if this rings a bell from question 4 from the midterm. In other words, anytime anything changes its position or its size, it sends a ripple through the vectors to all other objects and locations in the universe. The ripple, the pulse that moves through the vectors is like a collection of phase staggered oscillators. The vectors are the oscillators, and the ripple is like a pulse or a wave of information update through the vectors or the lines. In other words, when something exists, it creates a contribution to the field. When something changes, it sends ripples, pulses, wave motion through the field. Remember, all waves have a medium. We believe in sound waves, even though sound wave is not material, we believe in it because we can picture a bunch of air molecules in a big collection oscillating back and forth in a phase staggered manner. So a bunch of material air molecules, if they all vibrate in exactly the right way, in exactly the right space and time, they create a ripple or a pulse through the air molecules. So the air molecules are known as a medium. They are made of material particles, and then something immaterial, like information, flows through the air molecules, and we call that a sound wave. Well, what we now believe in the 19th and 20th century, ever since the late 19th century, we believe that ripples get sent through electric fields, and ripples get sent through electric fields whenever any change occurs. The information updates by a pulse or a wave pulse, or a wave pulse rippling through, like one vector moving, then another vector moving, then another vector moving, rippling through the electric field in the manner of a wave. And the reason we believe this is that Maxwell in 1879 actually decoupled field equations for the electric field and the magnetic field, and found out that the electric field in free space follows the wave equation. If you notice what's on the board right here, and I'm just about done, but look what's on the board right here. This is a true statement. I'm not saying you're going to have problems to solve on it or anything like that. You just might have true false questions about it. But what I'm saying is, as of 1879, it's been proven that in free space, in space between charges and between masses, the electrostatic field and also the magnetic field obey the wave equation. Do you remember this? This is the form of the wave equation. Only we used to have y as the dependent variable. Now I'm saying even the E field can be the dependent variable. The E field vectors can ripple through the E field in the form of a wave. But two weird things about that, and then we'll be done. One, so I'm saying when the Earth moves, how does the information update get to the sun? It gets there as a ripple through the electric field. Now that's fascinating to me and to many physicists, because we already spent most of this course establishing what it means to believe in a wave. But we've been saying what a wave, a non-material thing is a ripple or a pulse or a set of vibrations in a material medium. In other words, we believe in sound. We believe that sound waves are possible because there's air molecules to carry the sound. Sound doesn't carry in outer space because there's no material medium to carry it. What updates in the electric field are waves, but their medium is field vectors, which themselves are already non-material. So what I'm saying right now, and I'm just about done, I'm saying the beginning of the course, you looked at materials called oscillators, masses on springs. The middle of the course, you put a bunch of masses on springs together in your mind or in the lab and created an immaterial flow of information known as a wave. By the end of the course, you're looking at raw information just sitting in space and calling it a field. And now I'm saying, and it's immaterial. Fields are immaterial, just sitting in space. Now I'm saying you can send, or the universe all the time sends immaterial pulses through the immaterial medium known as fields. And those immaterial pulses through the immaterial medium known as a field, those immaterial pulses are information updates. Anytime anything changes in the universe, the new information travels through the field in the form of a wave, according to the wave equation. And if you remember the wave equation, the constant that gets squared right before the term on the right-hand side, the constant that gets squared right before there is the speed at which that wave travels. And it turns out, as you can see by the way this equation is written, the speed at which updates to the electric field travel is the speed of light, which we've known for centuries. I mean, we've known the speed of light for centuries. So what I'm saying in sum, and we are just about done, I'm saying, just to wrap this up, just so you know why this stuff is important, I'm not asking you to prove this on the test or ask you to solve problems on this on the test. I just want you to know why all this stuff matters, at least to me, is that it's not just that information. So the answer to Newton's question that he couldn't have known at the time, that he didn't know at the time, is when the Earth moves and the sun gets the new information, it gets to the sun in a finite speed, a very, 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 very fast, high, but nonetheless finite speed known as the speed of light. Like anything that happens on the sun, okay, is 93 million miles away from us. light travels at 186,000 miles per second. So the sun is so the amount of distance that the sun is away from us would take light 8 minutes to travel. The sun is 8 light minutes away from us. If anything happens on the sun at all, if it gets bigger, if it moves, if it gets smaller, that information gets to the Earth 8 minutes later. We don't know it for 8 minutes. I'm saying that information through the electric field or through the magnetic field travels at the speed of light, but I'm saying therefore something even slightly deeper. I'm saying it's not a coincidence that information updates to the electric field. That immaterial pulses through the immaterial medium known as the electric field, they all travel at the speed of light. They are waves, electromagnetic waves that travel at the speed of light. What I'm saying in the end is that's because that is what light is. What light is, no matter whether it's red light, green light, whether it's visible light or microwave light or X-ray light or gamma, what light is anything that travels at the speed of light. And anything that travels at the speed of light, what it is the speed of information, literal information. Light speed is the rate at which ripples flow through the electromagnetic field of the universe. Light is the rate at which one point in space tells another point in space what's going on. The speed of light is the rate at which different points in the universe communicate with one another. The speed of light is the speed at which the universe talks to itself. The speed of light is the speed of information. That's all I have to say. That's the point of the course. I'm going to shut down now. If you have any more questions, please text me or email me. I wish you great luck on the exam and great fortune in your futures. And thank you for being so patient for 2 semesters.